Welcome everyone, and we are going to start our discussion of exponential and logarithmic functions. So here we're going to start with kind of just talk about non-polynomial functions in general, because we've been so focused on polynomial functions, linear functions, quadratic, and then higher order polynomials, and then we talked about rational functions that we maybe need to start transitioning out of that polynomial land. So eventually what we want to do by the end of all these videos is to talk about exponential functions and logarithmic functions, and then different terminology related to them, and then graph, and then of course applications. Okay, so to begin, context, right? We want to start with that sort of idea. So, for example, we might have a growing city that has tracked its population since 2005. And so here's some sparse data. So I call it sparse because, well, we aren't given the entire data set. And we just want to look at the data to determine a possible model. Okay, now I actually copied this data into Excel. And so here it is. And all I'm going to do is make a little graph. So let's see, highlight it, insert. Scatter plot is really the best way to visualize this data. Okay, and it's kind of small. I'm going to enlarge it here. Okay, and so I can make this pretty. Yeah, I'm not going to spend the time doing it right now. But you can see that, okay, horizontal axis is time, vertical axis is population in thousands. So we can see it kind of starts like this and goes up kind of quickly. So now what I'm going to do is I'm going to add a trend line. Now, you might be familiar with making a trend line, and you know a trend line, it doesn't go through all the points, blah, blah, blah. So here's what a linear trend line would look like, or in other words, a linear model. Okay, linear model doesn't really hit any of the points. Well, that's not great. So then I'm going to go to options and go into more options, and then I get a polynomial option. So let's maybe just get rid of that linear trend line. Oop, I deleted the wrong one. And I'm just going to change it to polynomial. So now I do an order 2 polynomial quadratic, right? And if I wanted to, I can even display the equation. Well, that's a lovely quadratic function. But you can see that ends up fitting the data more, but still doesn't hit everything exactly. So if I look at this and I can continue increasing in order, and you can see as it moved a little bit, my equation got a little bit more complicated. 4, 5, okay, and 5, it looks like it hits almost all the points, maybe not that one so much. So polynomial function isn't going to exactly predict this. So that's why maybe polynomial isn't the best option. But if we look at a different model, there's this power model. Oops. JK, don't do that. But if we go back and make a trend line here, more options, and I do like an exponential model, that actually looks pretty darn good because it goes through all the points. So an exponential model is going to work, and we see if we display the equation, and this was pretty close to what I actually used, and I can't make that any bigger, unfortunately. It actually is going to model this data set quite well. And so the equation is 8 times e, okay, you might have to remember what that is, or we'll talk about it later, to the power of 0.0953 times x. Okay, so that could be the model that we use, and maybe that the city wants to consider in planning, for planning purposes. Okay, but the idea here is just to give you a context that our world in math isn't always linear or quadratic. It could be exponential, or it could be logarithmic, and that's what we're going to see in the upcoming videos.